I'm here with my assistant, Mitchie. He was almost 11 months old, to tell you about the Unit 3 lab, Solutions, Dilutions, and Conductivity. So in this lab, really the goal is to make a solution. Well, I'm not going to that. Make a solution if you know the concentration and volume. So the real issue here, concentration and volume, is you can't measure moles. So if we wanted to make, for example, this is not the concentration in the solution, but if we wanted to make like a 2 molar solution of, we'll go with sodium chloride, and we'll make maybe 0.5 liters of that, right? So how are we going to do that? Because this is not something that we can measure out into a beaker. We can measure out things like grams, and we can measure out this much volume. That's no problem. But how are we going to take this and get this to something that we can measure in lab? And the answer to that is moles. So anytime you see capital M, that's molarity. Capital M equals molarity, right? And so our molarity, the formula for that is the number of moles per liter, right? And so we have the liters right here, so that can be plugged in right there. And we've got the molarity right here, so that can be plugged in right there. So essentially what we can do, and if we remember, moles is related to grams, and grams is something we can weigh. So let's solve for moles. So I'm actually going to put that up here. Moles equals the molarity times the volume in liters. So our molarity here is 2 molar, and our volume in liters is 0.5 liters. If you had it in milliliters, you just convert it to liters. And so the number of moles that we have in this solution is actually 1 mole. Okay, but we could end up with like 0.1 moles, half a mole, 0.37 moles, anything like that. So from the number of moles, we know that number of grams is something that we can get, and that's something that we can weigh. So we can take the number of moles and do a ladder, and this is the molecular weight, and we already know that that's 58.44 grams of NaCl is the same as 1 mole of NaCl, and that's how much we need. So even just looking at that, we know that we would need 58.44 grams of NaCl to make a 2 molar solution at 0.5 liter total volume. So that's how you can do that, and the lab asks you to calculate this a couple different ways. The important things are using the molarity to solve for moles, and then multiplying by the molecular weight, number of moles by the molecular weight, in order to figure out the number of grams. Do we need a break, Mitchie? Yeah, it is kind of hard. I'm sorry. Okay, so next up is dilutions. So you're going to take that solution of, 2 molar NaCl. We'll have it in a little beaker here. And we want to take some volume of that, some amount, and we want to make a new volume at, let's say, 50 mils total volume. And we want to make, so total volume is going to be important because it's different than 50 mils of adding it to 50 mils of water. And how about, let's make it at 1 molar concentration. So we start off, we have like a whole bunch of volume here, but we don't need to add that all in. That wouldn't make a lot of sense. We want a new solution that looks like this, and we always want to figure out how much of this 2 molar NaCl we need to get that. And so the formula that we're going to use is C1V1 equals C2V2. And basically what this says, because this is the concentration, that's the volume, and we know from above that if you multiply the concentration by the volume, that gives you number of moles. What this is really saying is that how many moles of NaCl do we need to add into this solution right here in order to make this concentration. So our C1 is going to be that. Our C2 is going to be the new solution. Our V2 is going to be our new solution. And this is going to be our V1, and we don't know how much that is. So we're going to solve for V1. V1 equals C2 V2 over C1. So this is going to be 1 molar and 50 mils over 2 molar. Okay, and then these molars are going to cancel. Our volume is going to be left in milliliters because that hasn't canceled. And so our volume is going to be 50 divided by 2, which is 25 milliliters. So V1, we're going to need 25 mils of a 2 molar NaCl solution in order to make this new solution. And then in the lab, you're going to take this solution and make a whole nother solution. So this is labeled A, and then you're going to also make B. And the tricky part is now this is no longer, for the second part to make B, this is no longer V2 and C2. This is now what you're starting with. So this becomes, for this new problem with B, C1, and we don't know, again, V1. So even though we have 50 mils of it, we don't know what that is. And then you'd use the C2 and V2 over here in order to figure out the volume of this that you would need. Just like this was the V1, we want this new V1. So that's how a serial dilution will work. And a special note for that is, like, this is especially good for low concentrations, because if you're paying attention to lab, our grams are really, really kind of hard to measure sometimes because our gram balance only goes to like 0.1 grams. So if you needed like half a gram, that really would not work. Oh, that was a whole bunch of fun distractions. Okay, just because of accuracy, this is a better way for when you're dealing with low concentrations with a very small number of grams, small amount of solute. Okay, you're also going to use the molarity information to calculate the percent mass volume, and this is kind of nice because we know molarity is moles per liter. And we're going to know the concentrations of each thing. And we're going to have to do some conversions, and we want to end up, because the units of the mass are going to be grams, and the units of volume are going to be milliliters, and then we're going to multiply that by 100%. So we're going to use the moles, and we're going to solve for grams, and we're going to do that by multiplying the number of moles, which is going to be 1. Just to avoid confusion, we're just going to put 1 there. And then the molecular weight in grams. Right, and so these moles are going to cancel. That's going to give you grams. Grams is what we wanted. So these grams are those grams. Then you're also going to convert the liters to milliliters by remembering that 1 liter is 1,000 milliliters. Right? And then these mils are these mils. Okay. So one way you can do this is whatever the molarity is If it's like 2 molars, that equals 2 moles per liter, and then you would just plug that in here. So whatever the starting molarity is, that's what's going to go here. So this molarity, if it's 2 molar, that's going to go right here, because 2 molarity is the same thing as 2 moles per liter, and that's where that comes from. Okay, so that's a really kind of simple and easy way to calculate the number of grams per mole. Okay, the last calculation that you're going to do is osmolarity. Osmolarity. And that's the concentration in molars times the number of parts, number of ions. So like NaCl, that has 2 parts. Like any sort of sugar, and that's because in solution it's ionic, it separates into its ions. Anything that's like a sugar, C6H12O6, in solution it's going to just stay exactly the same, C6H12O6, because it's covalent, it doesn't separate. But things like, what's a good one? MgBr2, this is ionic, it's going to separate to 3 individual ions, 1 magnesium per formula, 2 bromides. Thank you, Mitchie. And then finally, where you're going to relate osmolarity to conductivity. And then you expect, as the osmolarity increase, the number of osmoles per liter increases, we expect that to be more conductivity because there's more things to carry the electricity. Okay, and that's everything I've got to say about that lab. Thank you.